Hi everyone. In this video, SSL protocol and its working is demonstrated by using Wireshark software. SSL is basically Secure Sockets Layer Protocol, which was designed by Netscape Corporation in 1990. And this protocol is used as a security protocol to ensure secure communication between web clients and web servers. It uses private key and public key to start the communication process. It has two subprotocols, record protocol and handshake protocol. During the SSL communication, there are two types of communication which takes place, that is asymmetric cryptography, which initiates the SSL handshake, and other one is symmetric cryptography, through which actual data is transferred. During SSL handshake, the client sends a hello message to the server in which it sends the complete details of the required communication process, and server checks the message and replies with the server hello message, in which server's detail, its public key and its other details are mentioned, along with the server certificate, which is authenticated by the client through CA, that is certificate authority. After the authentication, the client encrypts the message and sends it with the server's public key to the server. Server then decrypts the data through its server key and sends acknowledgement back to the client. After the acknowledgement is being sent, both of the parties, that is the client and server, have one session key which is further used for the communication. Both of the client and server use the same key to encrypt and decrypt the data for their further communications. Thus, the whole process of actual data transfer is the symmetric cryptography process, whereas the SSL handshake is asymmetric because it uses two different keys, that is the public key and the private key. Then we have SSL certificate, which is issued by the authorized certificate authority. It contains the owner's public key and the required information, which is formatted by the X.509 standard. It includes various informations, for example, version of the server, the serial number, public key, and few of the other things. And now let's have a look how the server actually works. So here this padlock shows that the connection is secured. Under the more information, we can check its certificate information. Here are the basic information regarding the Amazon certificate: its name, the issued authority, and period of validity. Now let's look at the traffic captured protocols, and we require the SSL or TLS. So after applying a filter, here from the client hello, we have begin the protocol handshake. Under this, we can see the source address, that is my local address, destination address, and the server's web address. Here is the frame information, the frame length 571 bytes, and then under the transport layer security protocol, that is TLS, or we can say SSL. See the client hello handshake protocol. Content type is handshake. It's defining the version of the protocol used, that is TLS 1.0. And in the second client hello, the source port is mentioned over here and the destination port. TCP payload, the data payload is of 517 bytes. Under the handshake protocol, we have the cipher suite, that is 18 suites it have. This is the list of the protocols or the algorithms which can be used by the client, which are sent to server. From these cipher suites, server would choose one according to its appropriate requirement and would respond back to the client. Here we can see server hello. In server hello, this is the handshake protocol. Reply from server. Length of server hello is 104. The version used by web server, that is Amazon, is TLS 1.2, and the cipher suite it choose to begin the communication is here. The session ID length is 32, and this one is the session ID. It is the key used by the server. And in the next step, it is the certificate status. In certificate status, the server sends its certificate to the client. Here we can see the certificate length, that is 4512 bits, and the status of the certificate under this, its length 471, certificate type. After the certificate is received, server would send back server hello done. Under this, server will authenticate the certificate. It will respond back with server hello done, which means that the certificate is accepted and the encryption will start from the next step. Here the server key would be exchanged. This is the algorithm used, and the signature algorithm RSA PKS is mentioned over here. Signature length 256 and the signature. Public key length is 65, and this is the public key which is determined after using this algorithm. After the server hello is done, client will exchange its key, and here is the change cipher specification and encrypted handshake message. Under this step, the handshake protocol is completed. Here the length of the client key exchange is 66. After the server sends its server key, the data is decrypted and the key is received by the client. So here is the length of the changed cipher spec, and after this key is decrypted, the further process will be in encrypted messages. Here are the TCP payload, the data, and the cipher keys exchanged. After the key is decrypted at the server end, it will reply back with server hello done. Here the public key used by server is mentioned, public key length, and the signature algorithm which is used, signature of the server. After the session key at both of the ends is determined, handshake replies by server hello done, and the clients exchange the keys, after which the application data is transmitted. This is an here it's written, this is an acknowledge to the segment and frame. So this means that the encryption has started and the further process will take place in encrypted data form. Here the recorded layer is application data protocol. Application data is the messages which are transmitted from server to client or from client to server in encrypted form, which is decrypted at both of the ends, and the communication takes place further. So this was the whole communication process. In the application data, we can check the Ethernet and Internet protocols, the destination address, source address, type of IP protocol, then the header length, which includes the data and the source and IP addresses, and the protocol which was used to perform the transmission process. Here, the transmission control protocol is telling the source port, destination port, the sequence and acknowledgement sent by the server. Here, the change cipherspec message includes the encrypted key, which would be decrypted by the client or the server, after which the process would take place. So this was all about SSL protocol and its working.